Good morning. Our experiment for today in physics lab, PHYS212 Fundamental of Physics 1, is experiment number 3 about projectile motion. So in this experiment we will see the projectile motion of a steel ball, and we will launch this steel ball using a launcher with 3 different tension. So here inside the launcher we have a spring, and as much as we compress the spring, we will have an initial velocity bigger. So we have tension 1, tension 2, and tension 3. So we have 3 tension in this launcher, and then we have 3 initial velocity. So we can launch this steel ball with 3 different velocity. As well, in this ballistic unit, we can adjust the angle, the initial angle at which we are launching the ball. So here we have the graduation of different angles. So we have 0 degree, 10, 20 degree, 45 degree, and the maximum of 90 degree. So we can change the angle at which we are launching the ball between 0 and 90 degree. However, during the experiment, the variation of the angle at which we are launching the ball will be between 20 degree and 70 degree with an increment of 5 degree. In addition, we have this table and the recording tape. We are using a recording tape because when we launch the ball and the ball comes and touches the table, when it touches the recording tape, it will make a black dot at the point it touches the table. Using a meter, if we measure the distance between the table and the bench, we can see that we are at 29 centimeter. The upper face of the table is at 29 centimeter from the bench. And same we have here between the bench and the initial position of the steel ball, we have also a 29 centimeter. While doing a projectile motion, and in order to measure the range of which is the horizontal distance or the horizontal displacement between the initial position and the final position, the range is measured at the same level of the initial position. And that's why we have to make sure that the table is at the same level as the initial point. And this is what we showed just now, that the distance from the upper face to the lab bench and from the initial position to the lab bench is 29 centimeters. So initial position and table are on the same level. Now we have to we have an angle theta at 20 degree, and we will launch the ball using the first tension, which is V1. As you can see on the table in the lab manual, we have to change theta between 20 degree and 70 degree with an increment of 5 degree for V1, and then for V2, and in the final step for the tension 3 or V3. So now I will launch the ball using tension 1 and at angle 20 degree, and we will see where is the touch position or the first touch position of the steel ball at the recording tape. At tension 1, we will launch the ball at angle 20 degree with V1, and as we can see here, we have the first touch is here. So we mention the first touch and we write 20 degree 1 to mention that it is for theta equal 20 degree and V1. Now we will change the angle to 25 degree and also at V1. So the position is here, 25.1. The range will be increasing since we are launching the ball with the same velocity V1. The range will be increasing between 20 and 45 degrees. At 45 we will have a maximum range, and then after angle 45 degrees the range will be decreasing. So from 20 to 45 the range will be increasing, 45 to 70 the range will be decreasing. So this is the angle 35. Angle 40. And this is the angle 45. So at angle 50 degrees we'll see that the range will begin to decrease. 50 is almost at the same position as the angle 40, and now we will see that the angle 55 will be similar to the range of the angle 35. The range for angle 60 will be similar to the range of angle 30. And we still have two angles to do for V1, which is the angle 65 and finally for V1 the angle 70. Now, after doing the first set of range for angles between 20 and 70 degrees and using the first velocity V1, we must measure the distance from the initial position to the corresponding points, which is the range. So here we have the range for angle 20 degrees, the range for 20 degrees, the range for 25, for angle 30, 35, 40, 45, and so on, till we measure all the ranges. After measuring the ranges, now we have to repeat the experiment using tension 2, and by changing the angle from 20 degrees to 70 degrees, and after that we redo the experiment using the tension 3. And similar, we have to change the angle from 20 to 70 degrees with increment of 5 degrees. What we know about a projectile motion, that the equation of range will be equal to V0 squared divided by G sine 2 theta. So here in our experiment we have three different values of the velocity V0. We have V1, V2 and V3. V2 is bigger than V1 and V3 is bigger than V2. So by increasing the initial velocity, the range will increase as well. So for angle 20 degree, for example, range at 20 degree using V1 will be less than range at 20 degree using V2, less than range at 20 degree using V3. Similar to H max, the maximum height, which is equal to V0 squared divided by 2G sine squared theta. H max is also will be increasing when the velocity increase. So if we use V2, H max will be bigger than V1, and if we are using V3, H max will be bigger than V2. And by doing the experiment, we will got this results about the ranges. So as you can see on the table, for the range using V0 equal V1 from 20 to 70 degree, we have the corresponding values 38.5, 45.8, and so on. But if we compare the values of 20 degree, let's say, using V0 equal V1, V0 equal V2, and V0 equal V3, we see at V1 and for angle 20 degree, we have a range of 38.5. However, for V2, we have a range of 85.5, and for V3, we have a range of 149. 149. If we compare another value at 45, which is the higher range at the corresponding velocity, for V1, we have a range of 60. However, for V2, we have a range of 128, and for V3, we have a range of 213 centimeter. So as you can see, by comparing the tables, the values of range in each table, we see that the values are increasing for the similar angle, since the velocity is increasing. Now, in the second step of this experiment, they are asking us to measure the maximum height. And in order to measure the maximum height, we are in need to use this ruler. And this ruler must be placed at mid-range. Since we are talking about a projectile motion, and as we have the x and y axis, the horizontal and vertical axis, here in our case we have an initial position. Let's say this is the lab bench level, and here we have the launcher unit. Okay, and this is the initial position. So initial position. If we draw a horizontal line, we have velocity V0 and theta 0. So we have V0 and theta 0. And a projectile motion is always a parabola. So the shape or the ball will do this trajectory, which is a parabola. This is the table that we have, table level. So the distance from the initial position to the final position is the range. So this is the range. Since the trajectory is a parabola will have a maximum height. The maximum height of a parabola will be at midway between the initial position and the final position, which is, so this is the H max measured from the initial level, which is the initial position, and the maximum height will occur at r over 2. R over 2. So that's why we have to place. This ruler at the mid-range. So, for example, for V1, for V1, we have at angle theta equal 20 degree, we have a range of 38.5. So we have to place the ruler at mid-range, which is almost 19.25. So we have to place this ruler at 19.25, and same for the other angle. So for example, for angle 40, we have a range of 58.4, so we have to place the ruler at 58 divided by 2, 29.2, at 29.2 centimeter. So now we move on the table, and we place the meter we adjust the starting point of the meter on the white line. Here we have an angle of 20 degree, and steel ball at V equal 1. So I have to place, we said that the range at 20 degree for V1 is 38.5, so 19.2. So the ruler is at 19.2 centimeter. And now we have to launch the ball, and look where is the touch position between the steel ball and the ruler. The touching position will be something in this zone, between 30 and 35. Between 30 and 35. So if I launch the ball, so the touching position is here, the contact is here at 33, 30 plus 3 centimeters, so 33. If we remove the distance from the initial position to the lap bench, which is 29, so we do 33 minus 29, we got 4 centimeters. So for angle 20 degree and V equal V1, we have a maximum height of 4 centimeters, 33 minus 29. Now we will change the angle to 25 degree, and we know that the maximum height will increase as with respect to the angle theta. So by increasing theta, the maximum height will increase as well. For angle 25, we have a range of 45.8 using V1. So 45.8 divided by 2, 22.9. So we must place the ruler at 22.9, so almost like that, and we launch the ball. So the contact position is almost here at 34, so we do 34 minus 29, we got 5 centimeters. We have to do the same for all angles and for all velocities. So if we continue by changing the angle for V1, we see that H max will increase with respect to theta, so from 4, and finally at 70 degree we will have a 27 degree as maximum height. However, for V2, we will start from 9 centimeter as maximum height at angle 20 degree, and we will get at 70 degree a maximum height of 57 centimeter. However, for V3, the maximum height will do a variation between 14 centimeter and 96 centimeter. So H max is increasing with respect to theta, as well as with respect to the initial velocity. In order to complete the lab report of this experiment, we must answer the question at the end of the experiment. that you can find in the manual at the end of the experiment. So, and one of the question is asking us to plot the variation of the range function of theta. So as we can see in this graph that we have three different plots. The lower one is for initial velocity v1, the middle one is for initial velocity v2, and the third one, or the higher one, is for a velocity, initial velocity v3. So as we can see, the bigger the velocity is, the higher or the bigger the range is as well. So that's everything about this experiment, and as a conclusion, we see that the range is there's a direct relation between the range and the angle, as well as to the velocity, the initial velocity, and the range will have a maximum at angle 45. However, concerning the maximum height will keep increasing, or is directly proportional to the angle and to the velocity.